Assalamualaikum warahmatullahi wabarakatuh. So we go to the next. We continue our discussion on the second example of general plane motion. We have a 25 kilogram wheel has a radius of gyration of kg is equal to 0.2 meter. If a 50 newton meter couple moment is applied to the wheel clockwise, determine the acceleration of its mass center g. You have to find what here. Uh, Ag. You have to find a Ag. The coefficient of static and kinetic friction between the wheel and the plane at A are mu s is equal to 0.3 mu k 0.25 respectively. So what you have to do basically draw the FBD. It's very important, FBD. You draw it. Okay. You have moment. You have moment 50 Newton meter. What else? You have a friction force. FF to the ref. For the example, you have weight. And then you have normal force. Okay. What is the kinetic diagram? Okay, you have what? You have AG to the right. There's no AG to the bottom to the top, and then you have alpha. This is very important to draw free body diagram and kinetic diagram. Okay, what else? In this problem, it's not mentioned. It's not mentioned. Not mentioned either sleeping or not. It's not mentioned. So when it's not mentioned, as I suggested to you before, you have to choose its role without sleeping. Okay, so as usual, summation of force in x. Summation of force in x to the right is positive. If equal to m a g x. So from the FBD, we have what? Negative FF. All right, for the force, and that's all. And we have the motion to the right. So negative FF is equal to M is the mass is 25 kilograms. AG X. The unknown here is AGX. The summation of force in Y to the top is positive, upward or upward is positive, is equal to MAGY. But don't forget before you draw it's easy for you. Draw the global axis. Alright, so we have what? We have N positive and W. Okay, N minus W. W is what? W is 25 times 9.81. Okay, 25 times 9.81. And here is M is 5. Sorry, M is 25. But there is no acceleration in X. Sorry, in Y. This wheel, this point G doesn't move up and down. So when it doesn't move up and down, the velocity, the acceleration is 0. It has only the component of acceleration in x. Okay, this one is 0. So you have what? You have FF as the unknown. You have AGX unknown, and then you have N as well as the unknown. Means that you have three. You have three unknown. You have two equations. You need one more equation. You need one more equation. Try to see if you need more than that. But of course, we have to come up with the third one. The third one is summation of moment. Okay, choose the point. It's better to choose point G lah. Try to point G. Clockwise is positive. Is equal to IG. If you use summation of moment at G, so it is equal to IG. Times alpha. So what is IG? Ig is given. Since the radius of gyration is given, so mkg square. The answer here, put 25 times 0.2 square. The answer is, I just write it down here. Just mathematics lah. Okay, 1 kilogram meter square. Okay. You have what? Moment here, 50 Newton. Clockwise is positive. And then you have what? W is not counted and also not counted, but you have to count the friction force. Okay. So friction force create a positive moment times 0.4 times FF. Ig is 1, alpha is alpha. But here you can see that how many unknowns here? You have FF, A, AGX, sorry. You have N, and then you have one more, fourth, which is alpha. Okay, you have three equation, three unknown. Three equation, four unknown. 1, 2. All right, now this is where the fourth equation comes in. Where when you assume it, as a roll without slipping, it's roll without slipping, you have AGX is equal to, by assume when you assume it's a row without slipping, so you assume this one is point IG lah, is RG, okay, times alpha. So that equation 1 reduced to equation 1 reduce, okay, change to what? Minus FF is equal to 25 times R 0.4. You replace AGX by this value, by RGA times alpha. Now I can say that. So I put it as an equation 1 prime. You can see that this is the first one. Okay, first one. And the unknown number 2, which is AGX, reduced to R alpha. So alpha here is unknown number 4. So you only have what? This one no more. Second one. Okay, third one. This one the first one, this one the third one. So you have unknown 1. You have unknown what? 2 is removed. 2 is has been removed because you replaced by A is R alpha. You have N, and you have alpha, which is number 4. So you have 3 unknown and 3 equation. What's equation you have? Equation number 2, equation number 3, and equation number 1 prime here, the new one lah. 3 equation. Since you have 3 equation, 3 unknowns, you can solve it. You can solve it. This is a simultaneous equation. You can solve it. So you can find that, you can get that your N, I put it N, is 245.25 Newton. F is equal to negative 100 Newton. It's a bit different with in the books and in the textbook, because in the textbook it assume FF to the right, but I assume FF to the left. That's why I got negative lah. And then, but if you change since you got the answer is minus 100 Newton, you can change lah. You can change. It's supposed to be to the right lah to get the positive value. To get the positive value, you change the direction to the right. It doesn't matter lah. And then alpha is equal to 10 radian per second. square, and then of course ag lah. Ag is 4 meter per second square. And then you have to check, since you assume it's a roll without slipping, you have to check either the ff is less than mu s time n. If it is less, so your assumption is true. Okay, what's your value of ff? Make it a positive lah, doesn't matter. The magnitude, choose the magnitude. 100. Is it correct? It's less than mu s time n. Mu s is what? Mu s is 0.3. 0.3 times 245, because n is 245, 0.25. Calculate it, you can get that 100 Newton is less than 73.6, where this is not true. It's impossible 100 Newton is less than 73.6. So your assumption where it's a roll without slipping is wrong. So you have to rework your your solution. How? Okay, let's start with this one. Okay. From equation 1. Equation 1 we have what? The pure one. Sorry, the pure. FF minus FF is 25 times AGX. Yeah? Sorry, FF 25 AGX. Okay. Equation number 2, what we have n. N. Sorry, yeah. Okay, sorry. Okay, n minus 25 okay. Okay, and the third one is 50 plus 0.4 times FF equal to 1 times alpha. One is a IG, this one alpha. So we don't use AG X equal to RG to A alpha anymore. No more. No more. So what you have to use is so the case is roll with slipping F. F is equal to mu K times N. Okay. So sorry. Okay, instead of FF, we replace equation 1. I put 1 prime here. Is negative mu Kn equal to 25 AGX. Okay, so here also n remain n, and then equation 3 we change it. I put a q prime. 3 prime is 50 plus 0.4 and replace ff by mu k, and is 1 times. All right, from this equation, from this 3 equation, equation number 2, 1 prime and 3 prime, you can solve it, where you can find an a, of course, 24525. Okay, And then you have FA, or sorry, FF is basically, if I remain use the F to the left, negative 61.31. Okay, suppose it goes to the right lah. And alpha basically is 25.5. Okay, and A is 2.45 per second square. This one radian per. Okay, basically there's no relationship between alpha and A because this case is a role with sleeping. All right, thank you very much. This is the final example for our subtopic general plane motion. If you look in the textbooks, there are two more examples. You can go through it on it. You can discuss among your friends, and later on, if you have a problem, you can comes to me. All right, thank you very much. I hope you understand the whole top the whole I mean content of the force and acceleration. And then if you have any problem, just let me know. Thank you very much. We have to continue our lecture with another interesting topic. It's not difficult. I think the next topic is not difficult as force and acceleration, work and energy. Because for work and energy, we can cover it in I think less than 8 videos to cover everything. Inshallah. All right. Thank you very much for your times. Okay. Assalamualaikum warahmatullahi